Hi, in this video we're going to look at two functions of which are quadratics. We're going to use a little bit of function notation and solve with using a bit of function notation and draw the graphs and find where the graphs intersect. So these two functions are given by f of x is equal to x squared minus 2 and g of x is equal to 3x squared plus 6. Let's find f of minus 2, f of 0, f of 2, g of minus 2, g of 0 and g of 2. Find x such that g of x is equal to minus 21. Sketch the functions of y is equal to f of x and y is equal to g of x on the same axis. Solve the equation f of x is equal to g of x. Hence find the coordinates of the points where the two curves intersect. So you've got f of x is x squared minus 2 and g of x is 3x squared. Sorry, correction, minus 3x squared plus 6. So, f of minus 2, what does this mean? Well, everywhere there's an x in here, you need now to replace it with a minus 2. So this becomes minus 2. Now, when you're substituting in negative numbers, it's a good idea to put them in brackets. So you've got minus 2 all squared minus 2. And then we get the next line will be 4 take away 2. 4 take away 2 is 2. Now, a common mistake here to say that minus 2 squared is minus 4. So just think about it. Put it in brackets, it's minus 2 all squared, so it becomes 4 minus 2. F of 0 is going to be equal to 0 squared minus 2. That's 0 minus 2, which is minus 2. And f of 2 will be 2 squared minus 2. 2 squared is 4, 4 minus 2 is equal to 2. Notice that this one is the same as this one, and the main reason is that quadratics are symmetrical. Right, now to g of minus 2. So g of minus 2, now it's going to be 3 times minus 2 squared plus 6. Now you need to be clear, what do we do first? Do we do minus 3 times minus 2 and then square, or do we do minus 2 squared and multiplied by minus 3? What we do is minus 2 squared multiplied by minus 3. So the next line is minus 3 times 4, because minus 2 squared is 4, plus 6, and that gives me minus 12 plus 6, which is equal to minus 6. G of 0 is going to be minus 3 times 0 squared plus 6. 0 squared is 0, 0 times minus 3 is 0, so we get 0 plus 6, which is 6. G of 2 is going to be minus 3 times 2 squared plus 6. Sorry, minus 3 times 2 squared plus 6. 2 squared is 4. 3 times 4 plus 6, and that gives me minus 12 plus 6, which is minus 6. Notice again here and here the answers are the same because quadratics are symmetrical. So find x such g of x is equal to minus 21. So if we've got minus 3x squared plus 6 is equal to minus 21. If we solve this, solving equations is about doing balance. Now the reason we write minus 3x squared plus 6 is equal to minus 1, because g of x is equal to minus 3x squared plus 6. So solving the equations, doing the opposite of plus 6 is to take 6. So you take 6 from this side, you get 3x squared, and then you take 6 from minus 21, you get minus 27. Minus 21 and then backward 6. Next, divide by minus 3. So on this side, if you divide by minus 3, you just get x squared, and then minus 27 divided by minus 3 gives plus 9. Opposite of squaring is to take the square root of both sides. The square root of x is x, the square root of 9 is 3, but we have to consider plus or minus 3 because 3 times 3 is 3, and minus 3 times minus 3 is also, sorry, plus 3 times 3 plus 3 is 9, and minus 3 times minus 3 is also 9. So we have to consider both cases, plus or minus 3. Right, using some sort of technology we're going to sketch. So I use GeoGebra here. Okay, so whatever technology you use. So here's my graph. So we've got, this is the graph of f of x is equal to x squared minus 2. and this is the graph of minus 3x squared plus 6. Now what are some of the characteristics of the graph? Both f and g are what's known as quadratics. This one is a U, parabolas, quadratics, so it's called a parabola graph. Okay, so this is like a U and this is like an N. So why is this one a U and why is this one an N? And why is this one look steeper than this one here? But it's also got to do with the number in front of the x squared. So in the first case, f is U-shaped because the a in x squared is positive. So if the number in front of x squared is positive, then you tend to get a U-shape. And then if g is n-shaped, as a in the x squared this time is minus 3, is negative. Also, because minus 3 is bigger than 1x squared, this will tend to be steeper. Okay, the vertex of this one here is actually at minus 2. Alright, so this point here on the quadratic is called the vertex. And the vertex on this one is here, which is at minus 6. Sorry, plus 6. Plus 6. Okay, and that sort of comes from here, when it says plus 6. Okay, and if you remember this one here, the green one here is x squared minus 2. So that actually gives me the vertex, and the plus 6 gives me the vertex of this one. So we're getting some sort of the characteristics of these quadratic graphs, transformations of them. Both curves are symmetrical about the y-axis. Okay, and that's quite an important fact when we did when we're doing with quadratics. Okay, when we've got minus 2 here and 2 here, we can see they're the same, and we get minus 2 here and minus 2 here. We see we get the same value. Okay, in the next part we are asked to find where f of x is equal to g of x. So that means I need to put x squared minus 2 equal to minus 3x squared plus 6. So I tend to look at the x squared and the minus 3x, which is the smaller, and then do the opposite thing. So add 3x squared to both sides. So you're going to get x squared plus 3x squared, which is 4x minus 2, and this side, if you do minus 3x squared plus 3x squared, you get nothing, so you're all left with a 6. Then we will add 2 to both sides, so we're going to get 4x is equal to 8. Dividing by 4 on both sides is x squared is equal to 2. And then the opposite of squaring is to take the square root, so we end up with, again, x is equal to plus or minus the square root of 2. To find the other coordinate, if we've got f of x is x squared minus 2, we only need to substitute into one of these now. F of minus root 2 becomes minus root 2 squared, because this is f of x is x squared minus 2, so it's minus root 2 squared minus 2. What is minus root 2 squared? Well, if you square the minus sign, it's positive. If you square a square root sign, they sort of cancel each other out because they are the inverse of each other. So you end up with 2 take away 2. 2 take away 2 is equal to 0. Similarly, when you did f of root 2, it's the same idea. And then you end up with 2 minus 2, which is 0. So the coordinates of intersection are minus root 2, 0 and root 2, 0. Alright, and then these are shown here on the graph here. So 1.4 is about root 2, so we get minus root 2, 0 here, and we see root 2, 0 here on the graph. So that's the points that we found by solving this equation here. Okay, so this has been a video to show you a little bit about function notation, how to use it, how to sketch quadratics a little bit, and how to then find the point of intersection of two graphs. I hope you've understood, and I thank you very much for watching.